Good afternoon. Today we are starting Unit 7. We're going to be working on probability this unit. I know that there are some of us who are itching to do our retakes from Unit 6, that test that we just got done with. Remember I said yesterday or the day before, not yesterday because we did testing yesterday, so I said on Monday that Mr. Schultz is out right now. And I haven't gotten the retakes from him yet. So I'm going to look at the practice work and see if I can make my own retakes based off of the practice work that he has given. So give me a little bit of time. This Friday is not going to be a retake day. We're doing something different with probability on Friday. So just know that next week I should have things available for doing retakes for Unit 6. Okay. All right, so today we are starting with PO39. It's a PO, so we need to know this. I can determine the number of possible outcomes of an event. So the first thing, now, possible outcomes of an event, we've worked with this in the past. We've had it in our math packets. So we're going to break down exactly how we can solve these. There are two different methods that we can do. So I'm going to show you the long way, and then I'm going to show you the short way. So probability is the likelihood of an event happening. The scale of probability is pretty much the percentage of chance that it's going to happen. So if we look at our scale, we would say this is 0%. It is not going to happen. All the way to 100%, this is definitely happening. Now, sometimes if we're doing extra credit on our math test, we could get over 100%, right? We could score 102%, 106%. For probability, it either, yes, it's happening 100% sure, or 0% definitely not happening. There's no over 100%. There's not, well, there's a 150% chance it's going to rain today. No, if it rains, it's a 100% chance it's going to rain.
Then wouldn't it double rain?
Yeah, there's no double rain.
Double whammy. So
we have 0%, not going to happen, 100% definitely happening. 50% is part way. You have a 50-50 chance of it happening. Not quite sure. 50% chance. So then if we look at below that, there's 25%. And anything that's under 50%, we're going to say it's not likely. Okay. 50% chance, it's half and half. Could go either way. If it's under 50%, it's not likely to happen. Cole and Edward, please stop. So if we look over on the other side, we've got our 75% is the middle, that median of the upper half. So on this side, it is likely to happen. So if it's 67%, it's more likely to happen. If it's 88%, it's really likely to happen. Okay, the closer you get to that 100%, the more likely it is to happen. The closer you get to the 0%, the less likely it's going to happen. To determine how many possible outcomes there are for an event, we need some way to figure out everything that could possibly happen. So there are two ways to do this. Okay, so there's reasons why we would use each way. So we're going to talk about the different ways. The first one is our probability tree. Whoops, too far. So we're going to look at flipping a coin. And let's say we're going to flip that coin 3 times. How many possible outcomes could there be? So if I'm going to flip my coin once, I'm going to erase that. Shh. I'm going to call that flip 1. So if I flip that coin one time, what possible outcomes could I have? Andrea?
You have a 50% chance of heads and 50% chance of tails.
So I have a chance to get heads or I have a chance to get tails. So I'm going to start my probability tree right here. There's me. I flip my coin and I could get heads or I could get tails. Those are my possible outcomes. Heads or tails. So now I'm going to go to my flip number 2. Now I had somebody ask me about this when we were after we did our math test yesterday. They said that they had a variable with a sub number. So if we called flip 1, if we called that F, if our flips are F, that would look like F1. That's my flip number 1. Then I have flip number 2. That's all that sub number is doing is just saying, yep, it's still a flip. It's just another one of them. Caitlin, did that make sense? Because you were the one that asked me about the sub, right? So all it's doing is saying, yep, it's just another version of it. Okay. So there's no math that you have to do with the sub number. It's just differentiating between flip 1 and flip 2. Okay, so if I flip my first coin, I flipped and got a heads. What possible outcomes do I have when I flip coin 2? I'm going to flip it a second time. Flip coin 2. Maddie?
Don't you still have a 50%?
I could flip heads, or I could flip tails. Well, let's say I had a tails the first time, and I flip it the second time. What possible outcomes could I have from that flip? Maddie?
You could either have a 25 to 75.
Nope.
Wait. Or you could have
I have a coin and I'm going to flip it. I'm flipping it a second time. What are my possible outcomes? I'm not asking for percentages. Just tell me, what could I flip?
either heads or tails.
Heads or tails again. It's one coin, got heads on one side, tails on the other. I'm going to get either heads or tails. Well, it says I'm flipping it 3 times. So I flipped heads the first time. I flipped heads the second time. What possible outcomes could I have for my third flip, Paul? I can flip heads. I can flip tails. What about if I had flipped tails that second time? Andrea?
You could hit flip heads or tails.
Heads or tails. What about if I had flipped tails the first time and I flipped a heads the second time? What could I flip the third time, Naveen?
Heads or tails.
Heads or tails. And what about if I flipped a tails and then I flipped a tails? What could I flip the third time, Naomi? Either heads or tails again. So I'm going to look at all these and say, okay, now I can write down what my outcomes could be. So if I flipped a heads, and I flipped a heads, and then I flipped a heads, that would be heads, heads, heads. What if I flipped a heads, and I flipped a heads, then I flipped tails? That would be heads, heads, tails. See where I'm going with this?
Yeah.
Now we're going to say heads, tails, heads. What would my next possible outcome be? Caitlin?
Heads, tails, tails.
Heads, tails, tails. Well, now we're going to do it if I flip a tail that first time. Paul?
Tails, tails, tails.
Okay, we could do tails, tails, tails. Tails, tails, heads. Tails, heads, tails. And tails, heads, heads. So I can see all the possible outcomes that I could get. And I can count them up. 1, 2, 3, 4, 5, 6, 7, 8. And I know that there are 8 possible outcomes if I flipped my coin 3 times. So let's look at doing a probability tree with clothes. Shh. You have 3 pairs of pants and 4 shirts. How many possible outfits can you make? Well, to do our probability tree, to make it easy for us, we're going to put colors to our pants and colors to our shirts. And we're not going to repeat any color, so we can just use the first letter. Okay? So let's think of colors that have a different first letter. So if I want to look at 3 pairs of pants, what colors could I have for my pants? Molly?
Black, blue, and white.
I don't want to have the same letter to start to make it easy. So if I do black pants, I could do white pants. What do I want my third pair? Red pants. Ooh, some hot pants. I like it. Okay, so we're going to do black pants, white pants, and red pants. So now let's look at our shirts.
Yellow, orange,
Shh. Oh, I heard yellow.
orange,
I heard orange.
green,
I
burgundy.
heard
Hot
green.
Burgundy. Hot pink.
Now, if I were to put burgundy on here, what problem would I have?
Black.
I have black with a B.
Maroon. Pink.
Maroon.
Turquoise.
Lots of colors. Oh, kindergarten teachers are proud everywhere that you guys know your colors. Okay, so I'm going to start out right here. What should I put next? What should I put for my first possibilities? Okay.
So you could do. Okay, so you use pants.
So I'm going to start out with pants. What color pant choices do I have? I have black. I have white. And I have red. So then I have my shirt options. That is going to be like flip 1, flip 2. We first have to make our choice with pants, then we have to make our choice with the shirts. So coming off of my black pants, what choices of shirts do I have? I have yellow, orange, green, and maroon. So that's 4 possible outcomes with my black pants. Let's look at my white pants. I could have a yellow shirt, an orange shirt, a green shirt, and a maroon shirt. Oh boy, look at my red. Oof, I'm running out of room. Yellow, orange, green, and maroon. And I'm kind of running out of room here. This is the downside of doing our probability tree. The more options you have, the bigger your tree gets, and the more room you need. So that is one of the drawbacks of doing a probability tree. Let's look at what outcomes we could get. This is the bonus. This is the positive advantage of doing a probability tree, is we can easily see the actual outcomes. If your question is, what outfits could she put together using all of these choices, you could say, well, a black shirt and orange, or black pants and an orange shirt. She could do a black pants and a maroon shirt. So you can know what those actual outcomes are. So we're going to write them out. It could be black pants, yellow shirt, black pants, orange shirt, black pants, green shirt, black pants, maroon shirt. Then we're going to do it for our white pants. White pants, yellow shirt, white pants, orange shirt, white pants, green shirt, white pants, maroon shirt. Now let's do it for our red pants. Red pants, yellow shirt, red pants, orange shirt. Oof, reminds me of fire. Red pants, green shirt, and red pants, maroon shirt. Well, that would be a little clashy. Red pants, maroon shirt, not a good choice. So how many possible outcomes would there be? How many possible outfits could you make, Sam? 12. So we counted them all up. There are 12. Any questions on the possibility tree? Probability tree. Sorry. Thank you. Possibility, probability, kind of the same thing. Just saying. So, one thing I talked about was how, once we got up to 12 outcomes and we were running out of room. So there is an easier way to do it that takes up a whole lot less room. So we're going to look at that counting principle and see what that means. So let's look at, thank you to my friends that are being respectful and courteous and quiet. Counting principle, we're doing the same 3 coins. Over on this side, we're going to say number of outcomes. And then we're going to label them. Flip 1, flip 2, flip 3. I flip that coin the first time. How many possible outcomes are there? Chase? 2. I could get heads or tails. Now I'm going to look at flipping that coin a second time. When I flip that coin, how many possible outcomes are there, Maddie? 2. Now I'm going to flip it the third time. How many possible outcomes when I flip it a third time, Edward? 2.
Big brain. Big brain.
Wouldn't that get a different answer than you got?
He's not done. He's not done yet.
I am not done yet. And some of us are figuring it out. What do you think I have to do, Owen? What? I'm going to multiply all my possible outcomes together. 2 times 2 is 4. Times 2 is 8. Okay, friends, remember, we are. So, basically saying, oh my goodness, it's so much easier. Okay. Probability trees, we need to know how to do them because sometimes instead of saying how many, they'll say list the possible outcomes, possible outfits that they're going to wear. So if they're going to say list them all out and you do the counting principle, does the counting principle tell us what the outcomes are? No, it just tells us the number. So there's a reason why you do one. There's a reason why you do the other. It is a whole lot easier. Okay. Maddie.
What to the power work? Or is it only work if it were easy?
So for the coins, saying 2 to the third power works, but that's not going to always work because it's not always the same number. And we're going to see that with our next example. So we don't want to get into the habit of saying, oh, it's to an exponent, because it usually is not. Go real quick. Okay, so let's look at those pants and shirts. What would that look like? I'm going to have number of outcomes. How am I going to label the top? What should I put on the top? Andrea?
Pants or like.
So I'm going to put pants for my first choice, and then I'm going to put shirts. So how many outcomes do I have with my pants, Charlotte? 3. There's 3 different pants, so my number of outcomes could be 3. How many shirts there, Finn?
4.
4. There are 4 different shirts, so I have 4 different possible outcomes. Then I'm going to multiply them together. 3 times 4 equals 12. And see, that's, Maddie, is why we can't do the exponents, because they're different numbers.
Yeah, I was thinking of that. Well, I was still raising my hand, and then you kind of, and I was like, oh.
Yep. Andrea?
I was just going to say something.
Okay. Shh. Let's look down at the bottom of the page. A password with 5 letters, and the letters may repeat. So think about if you were making a password. We don't want to use words. We want to use random letters. They could end up forming a word, or they could just be random letters. The letters can repeat. And we're going to make a new password, because goodness knows they always want us to change up our passwords, and we have passwords for oodles of things. So, what am I going to start with? What am I going to write? Cole?
Numbers of outcomes.
Numbers of outcomes. Because we just saw how much easier it is to do the counting principle, and it's not asking for the actual password combinations. It's just asking for how many. So we don't need to do the probability tree if it's not asking for the actual passwords. We just need a number. So we're going to write number of outcomes. What am I going to put at the top? Maddie?
L1, L2, L3, L4.
Yep. L1 for letter 1, letter 2, letter 3, letter 4, and letter 5. So, how many possible outcomes do I have for my letter 1? Joseph? How many possible outcomes do I have for letter 1?
8.
How many letters are in the alphabet, Joseph? So how many possible outcomes do I have for letter 1? 26.
I got 8 because you can only put in 8 units in password.
Well, it says a password with 5 letters. So that's why we have 5 choices. And letters can repeat, so you can pick any letter of the alphabet, because this is not case sensitive. Sometimes it has to be uppercase, lowercase. This isn't case sensitive, just a letter. There's 26 letters. So for letter 2, how many possible outcomes do I have? You're right, because the letters can repeat. So we have a choice out of 26 again. So letter 3 is going to be out of 26 possible outcomes. Letter 4, how many outcomes, Sam M? 26. Letter 5, Leah? 26. So what math am I going to do to solve the equation? What is my calculation that I have to perform? Izzy? 26 times 26 times 26 times 26.
26 is the power of 5.
So, how many password combinations, how many possible passwords are there? Oh, way more than a million.
Oh my god. Oh my gosh. Oh, it's a
14. Paisley.
11,881,376. No, yeah, 36. No,
3 what? 376. So 11,881,376 possibilities for how many passwords we could get. Now imagine if we did a probability tree with that. Can you imagine how big it would be? We would have our first letter A. That first letter A would have 26 just for the A. Then B would have 26. Whew. Well, then we have letter 2 could be an A and 20. Oh my goodness.
That's already too
This,
many.
yeah, it's already overwhelming my mind. Joseph?
Basically, it would take 50 years to grow that.
I'm sorry, say that again.
It would take 50 years.
It would not take 50 years. It would probably take all of 5 minutes. It's not that challenging. You just have to be, your hands will get
And
tired.
you have to write down
Trees
the
like
possible
that
outcomes.
If we had to write down the possible outcomes, yeah, it would take even longer. Let's look at our next one. It's very important that you read the question completely. And you're going to see the big difference it makes when we read it completely. How many possible passwords can be made if the letters cannot repeat? So I'm going to start off the same way. Number of outcomes. And we have letter 1, letter 2, letter 3, letter 4, and letter 5. How many possible outcomes do I have for letter 1, Paul? 26. There's 26 letters in the alphabet. How many possible outcomes for letter 2, Sam M? 25, because we cannot repeat. If we use that A, we can't use it again. So now we only have 25 possible outcomes. Ethan, how many for letter 3? 24. Cole, how many for letter 4? And Edward, how many for letter 5? So now our calculation's going to look a little different. We're going to do 26 times 25 times 24 times 23 times 22. Jocelyn, what does that equal?
7,893,600.
Just 600. 7,893,600. One small change was made. Letters cannot repeat. Almost 4 million less passwords. So making that small change made a huge difference on our answer. It is that important that you pay attention. Edward and Briggs, we are not working ahead. So I shouldn't see you working on the next page. Thank you to my friends that are following along. I'm not up here just talking for fun, even though I love it and I do enjoy it and I have fun doing this kind of stuff. I'm talking for a reason and I need us to pay attention. Easy.
Oh, is 87,700.
Yeah, so when I rounded up to almost about 4 million, I was close,
Yes.
right? It is rounding up to 4 million. All right, let's look at our next page. Ashley, I'll take that one. And then open up to PO39. All right, so determine the possible number of possible outcomes. show your work. So this is a key thing right here. Because some of us are saying, oh, I just have to multiply this by this by this, and I'm going to put it into my calculator, and I'm going to write the answer. Is that showing me what work you did? You need to, bare minimum, you need to show me your calculations that you're performing. If you're saying, I need to actually write it all out, then write it all out. You can do number of outcomes. And let's figure it out. You flip a coin twice and roll a 6-sided die once. So I'm going to flip once. I'm going to flip twice. And I'm going to roll once. How many possible outcomes are there from flip 1? 2. How many from flip 2, Owen? Dose. How many possible outcomes when I roll the die? Paul? I'm going to roll that dice and I only have one option? Think about it. How many sides are on that dice, Paul? So when I roll that dice, it could land on the 1. It could land on the 2. It could land on the 3. It could land on the 4. It could land on the 5. It could land on the 6. So if it has 6 sides, how many possible outcomes are there? 6. So then I want to show my calculation because Miss Gambino said you must show your calculation that you are performing. So you can do the outcome if you need to write it out like that. Bare minimum, you need to show what calculation you're performing. So 2 times 2 times 6. What is that, Finn? 24. So there is no just writing the answer. Make sense? You have to at least show me your calculation you are performing. As you glance down on your page, are we feeling confident? Or is there anyone that we go, ooh, that one kind of confuses me? Okay, Paisley would like us to try the pizzeria and then we're going to work on our own. So, number of outcomes. Shh, thank you to my friends that are being silent. What is my first possibilities that I'm going to put on there, Paisley? Crust. So I'm going to put a C for crust. What's my second choice, Paisley? Toppings. And what's the last one, Paisley? Sizes. So how many possibilities of crust do we have? We have 4 types of crust. How many possibilities of toppings do we have? Oh boy. 15, you're right, Ryan. I would like all of those unless one of them's anchovies. No anchovies. I forgot about pineapples. Mateo likes pineapples. I do.
Cheese is the only suitable topping for a pizza.
I like my veggie pizzas with as many veggies as I can get. Oh, we are not done yet. Shh. How many choices do I have in sizes? Cole? 5. So then I need to do my calculation. How many different possibilities do I have, possible outcomes for my pizza, Gavin? 300. Oh my goodness. I have 300 pizza choices to make. Pizzeria does have a lot of options. Shh. How are we feeling? Give me a show with your thumbs. Are you feeling confident on this one? Not so much, or we really don't get it? Shh. Thank you again to my friends that are silent and are showing me their silent thumbs. Okay, looks like we're feeling very confident on this. I'm going to let you get to work. For my friends at home, we hope you are doing well, and we hope to see you soon.